Hello and welcome to Maths Academy. I am Noor Alam, Maths faculty and founder of Maths Academy. Today our topic is continuity, but in this class we are only discuss the some tips, few tips on the continuity which is very helpful in the exam purpose. So now we are not going to solve any question in this video, but some tricks which is very helpful for the IIT JEE. So now we are going to start by the definitions of continuity or not continuity. I think this topic will be the differentiability. Okay, now this continuity we have already discussed in the last class. So now today's topic is not continuity, tips on it will be differentiability. Okay, now we are going to change the topic. It will be wait, it will be differentiability. Okay, now how to change this one. Eraser is not working. Can we use ratio tools? No. Yes. So tips on continuity, tips on differentiability. So today our topic is tips on differentiability. Okay, so now we know that all of you know that about the definitions of differentiability. So consider a function y is equal to fx and consider one point x is equal to a, where we are going to consider the differentiability of the function. So all of you aware of the left hand derivative of the function. So it will be f dash a minus, which is equal to limit h tends to 0 minus f of a minus h minus f of a divided by minus h. When you are taking the right hand derivative f dash of a plus, it will be limit h tends to 0 plus f of a plus h minus f of a, then whole divided by h. This is known as the left hand derivative and second one is known as the right hand derivative. If both the values are same, if f dash a minus is same as f dash a plus, then we say that the function is differentiable at the point a and we should write f dash a. But now there are some lines which we call the vertical tangents. So actually when we are going to calculate the derivative, we are getting the slope of the tangent. But if the tangents are vertical, all of you know about this formula will not work. These definitions that you are going to calculate left hand derivative and right hand derivative, it will not work for the vertical tangent. So it will not work for vertical tangent. So now for vertical tangent, which formula we will use so that we can calculate whether the function is differentiable or not at that point. Okay, now so in case of the vertical tangents, this formula will not work. So in that case, suppose our point is x is equal to c. So c comma f of c is the point on the curve. If we calculate the derivative of this function f dash c, which is equal to limit h tends to 0. Now if we are taking f of c plus h minus f of c divided by h, and this modulus value is infinity, then we say that the vertical tangent at that point we have the vertical tangents. Since the vertical tangents does not satisfy the left hand and right hand derivative, so we consider the modulus, and the modulus value will be the infinity. That means from the left hand side the slope of the tangents will tend to the plus infinity, from the right hand side it also tends to the plus infinity, or both of the tendency will be going to the minus infinity. So that is the interpretation of this. Now sometime we have the curve and we have some interval. At the end point we are going to calculate the derivative. So if the at end point, if you have this kind of result, suppose f dash of a plus, so just you are taking the right hand derivative at this point. So limit h tends to 0, f of a plus h minus f of a, then divided by h. If this point is infinity, or f dash of b minus, here also you are getting limit h tends to 0, then f of a plus h minus f of a, then whole divided by h, and it is also infinity. Then you can say that one thing, Achha, here the point will be not a, it will be the point b, okay. So in that case you are saying that the function is having the vertical tangent at the end points b minus h, if you are consider. So now in this case you are getting what? You are getting the infinity only, okay. Now so now the question arises, what is the vertical tangent here? What is the actual meaning of vertical tangents? So here the point arises, what is our vertical tangent? What is the vertical tangent? So vertical tangents, in case of the vertical tangents, slope approaches plus infinity from both sides or minus infinity from both sides at the point of the curve. So we are taking one graph, try to make you understand about the tangent. So like here we have one part of the graph, here we have another part of the graph. So here you notice that the curve having the tangent which is the vertical, okay. So here we have the vertical tangents. Now if you consider the corner points that I have given you the example, so now you can take the example of sine inverse x. So this one and this one you can say. So here at the point pi by 2, at the point 1 you have pi by 2. So at this point and at this point we have the vertical tangent. So this is 1 and this point is the minus 1, okay. Now so this is the definition of vertical tangent, where the left hand derivative and right hand derivative RSD both tends to plus infinity or both tends to minus infinity, then you are getting the vertical tangents. The diagram is not looking good. I change the diagram. Suppose our diagram is like that. Okay, now so here you have like tangents at this point you have, okay. Now just the curve changing its nature, the left and the right of the point, okay. Now this one, so this is the vertical tangents and this is the curve. So now here my purpose is to explain, when the vertical tangents exist, then it does not follow the definition of the left hand and right hand derivative. So in this case we are taking the modulus and we are trying to get the infinity, okay. Now in case of the vertical tangent from both side, left hand limit or right hand limit, either they tending to the plus infinity or they tends to the minus infinity, okay. Now so next point, what is the relation between the continuity, relation between continuity and differentiability, This relation is very helpful to solve the question of IIT JEE. Few questions with the help of these results you can easily solve. Number 1, continuity. If a function is continuous at a particular point, So continuity does not always imply differentiability, does not implies differentiability at that point. If a function is continuous at a point, it does not mean that it is differentiable at that point. I am considering here the point is x is equal to a. So if the function is continuous at a point, it does not actually mean that it is differentiable at that point. Non-continuity. A function is not continuous, discontinuous at the point x is equal to a. It always implies the function is non-differentiable at that point. Non-differentiable. Okay, now take differentiability on the left hand side. So before the imply sign. So now differentiability, if the function is differentiable at a particular point, differentiability, it does not it is always means that the function should be continuous at that point. So differentiability always implies continuity at that point. Now not differentiability, a function is not differentiable at a point. Not differentiability or non-differentiability, since I use the here word none, so you can write non-differentiability. So non-differentiability does not implies non-continuity. All of you are aware of these four results, but the fifth result very few students apply in the exam hall. So what is our fifth result? This result is I can use the different color here. So now if the function is non-differentiable, f is not differentiable at a point, non-differentiable at x is equal to some point a. So that means left hand derivative at the point x equal to a is not equal to right hand derivative at that point. But the extra condition is both are finite, left hand derivative as well as right hand derivative. If both are finite, then these whole things always implies f is continuous at that point, continuous at that point a. So your function at that point is not differentiable, that means left hand right hand derivative both are not equal, but they should be the finite. So one example you can consider, that very well known example, in case of a mod function, you notice that mod of x is not differentiable at the 0, but what we can see that at this point 0 the function is not differentiable, but the left hand derivative as well as right hand derivative are the finite. So right hand derivative we are getting here 1 plus 1, and left hand derivative we are getting minus 1. So now plus 1 is not equal to minus 1, but the finite number, but finite. So as a result you notice that at this point 0 the function is continuous. Okay, now is it clear to all? Now coming to the next point that I am going to describe here, you can say that it is, next point is explain about the slope, explain about the slope of the tangent at the sharp corner, then cusp and vertical tangents. So in these three cases, what actually happened to the slope of the tangent, vertical tangents? So corner, first point sharp corner, next point is cusp, and third point is vertical tangent. So now from the diagonal we try to understand. So now for the sharp corner we can use this mod function, because it is very easy to remember. So first of all we are using here for the SERP corner I am using here mod function. Okay now, so this is our definition of mod. So y is equal to mod of x, this is our function. At the point 0 function is not differential, but right hand derivative is +1, left hand derivative is -1. So here you can say that at a particular point f dash a plus is not equal to f dash a minus, but not equal, but both are finite, but both left hand derivative and right hand derivative both are finite. So this produce the SERP corner at the curve, both are finite. So this will produce SERP corner. Okay na? So that is the condition for the SERP corner, that at the point where you are getting the SERP corner, so there the just right hand and left hand side, the slope of the derivative, the slope of the tangents are actually finite but not equal. Okay na? These things you have. Now here you can consider also some curve. Suppose here you can notice that if I consider 2 sin inverse x, so curve of this like that. Here here you can get this type of curve. So here SERP corner present at the point, at this point. Now if you consider y is equal to sin inverse x, so in case of y is equal to sin inverse x, you notice that at the end point, we have the SERP corner, so tangent does not exist. Okay now, so now next we have this point CUSP. So CUSP actually it is what your, suppose you are having the function at a particular point, the right hand derivative approaches suppose plus infinity. In that time left hand derivative at this point approaches minus infinity or opposite happen. That means both are tending to infinity but opposite in sign. So in this case you are getting the CUSP. So your CUSP will be what? It's look like in this way. So now this tangents approaches to positive infinity, one tangents, another tangents is approaches to negative infinity. Okay now, so in this case you are getting the this one is the positive infinity and this one is approaches to negative infinity. So in this case you can say that at this point you have the curves, at this point you have the CUSP at this point. So at the point on the curve where when you are taking the slope of the tangent just after the point and the before the point, you notice that your the slope, that means tendency of the slope to move towards the infinity but in opposite directions. Okay now next is vertical tangent. Just I told you in case of the vertical tangents what will happen, the derivative at the particular point where you are getting the vertical tangents, so suppose tending to plus infinity, so at that point left hand derivative also tending to positive infinity, or it will happen that both tends to minus infinity. Okay na? So where both are tending to the same infinity, left hand derivative as well as the right hand derivative, so in that case what will happen, your tangent is the vertical tangent at that point. So now we are going to draw the vertical tangents. So suppose at this point you have vertical tangents like this one, okay, like this one. So now here we have these things, here we have vertical tangents we have. So in case of the vertical tangents what we notice that so here when we move from left to right, the tendency of the tangent is same. It is either plus infinity or minus infinity. Slope will be either positive infinity or it will be the negative infinity. If opposite infinity, then you get the CUSP. If they are not infinity, finite number but not equal, they generate the SERP corner. But both are tending to the same infinity, positive or negative, then you are getting the vertical tangent. So these are the basic difference between the sharp corner, cusp and the vertical tangents. Sharp corner and the cusp and vertical tangents. So now where we will check the differentiability, where in which case we are checking, at which point we are checking the differentiability of the function. So now this is the next point that I am going to describe. All the points where the continuity is required, at that point you should check the differentiability. All the points where the continuity required. So at those points you should check the differentiability. And second point, at the critical points you should check the differentiability. At the critical points, so critical points means if it is the box function, then you should check where the box is. If it is the modulus function, then you have to check for the where the modulus is 0. So at the critical points of modulus function and ITF, so at their critical point you should check the differentiability. Okay now question arises, what is critical point? Next is, what is critical point? Critical point is the point where the first order derivative either 0 or not defined. So here suppose y is equal to fx is a function, then critical point are those points where f dash x is 0 or f dash x is not defined. So those x are known as the critical points. Those x are called critical points. Okay now if you take this example, y is equal to mod of x. So here you notice that at x equal to 0, derivative y dash does not exist, not defined. So therefore x is equal to 0 is the critical point of this function. Now if you are taking y is equal to sine inverse of x, its derivative is y dash, which is equal to 1 by root over 1 minus x square. So y dash is not defined at x equal to plus and minus. So these are the points, these are the critical points where you have to check the differentiability of the function. Okay now coming to the next point. Next is, suppose you have the function f and g. These are the properties which is very important when you are solving the questions. If f and g both are differentiable, so in that case f plus and minus g, f into g and f divided by g provided all are differentiable. Okay now next is, suppose f and g both are not differentiable. If both are not differentiable, f and g both are not differentiable, we can't say anything about plus and minus f into g and f by g. It may be differentiable, may not be differentiable, depends on the question, you have to solve it. Now third point, if one function is differentiable and other function is not differentiable, then what will happen? Then f plus and minus g, this function definitely not differentiable, but we can't say anything about their product and division. So we cannot make any comments on their products. F into g, f by g, in this case we can't say anything. So now consider one example so that you can understand this, these ideas you can understand. Now coming to one example, suppose I have one function fx which is equal to the sum of the function x plus mod of x. This is the question 1, and gx is a function which is equal to x into mod of x. Now they are asking at x equal to 0, in both cases you should consider the differentiability. So first of all, here this function is differentiable, this function is not differentiable. So if one differentiable, another is not differentiable, then their addition should be the not differentiable at that point, not differentiable. So in the graph also you can notice that mod of x graph, when you are taking, so suppose I am taking fx function as like this. So when you take positive, it will be 2x when x is greater or equal to 0, or otherwise 0 when x less than 0. So now when we draw the curve of this function, it will be look like this. Now it will be look like this. So this is the y is equal to 2x when x greater or equal to 0, y is equal to 2x when x greater or equal to 0, and next we have for less than 0 we have y equal to 0, that means x axis, this one. So what you notice that at this point, at the origin, you are getting the sharp corner, because the reason is after the 0 and before the 0, the slope of the tangents are different but finite, so sharp corner generally produced. So as a result, here the function is not differentiable. Now come to this this point. Here you can write gx as x square when x greater or equal to 0. Gx is minus x square when x less than 0. So now you are going to calculate their differentiability. You are going to check their differentiability. In a graph you can very easily check. It is the upward parabola. It is the upward parabola like this one. It is the upward parabola, first one like this, and second one is the half portion of the parabola like this. So you can draw by this one. So here you notice that here you are not getting the sharp corner. Actually at this point 0, you have the tangent, which is the horizontal tangent, and the slope of the tangent is 0. Okay, now so therefore in this case the function is differentiable. In this case function is differentiable and the value is 0. So here one function is differentiable starting in the initially, this function is not differentiable, but what you observe that their product is the differentiable. So we cannot say in case of the product, in case of the multiplication, or in case of the divisions, we cannot say anything, we have to solve it. But in case of addition and subtraction, one is differentiable, one is not differentiable, then we can easily say that their result is addition or subtraction is not differentiable. In the next video I am going to make one thing, that is the some questions generally come in the IIT JEE, which is based on the topic continuity and differentiability together. They ask the question, check continuity and differentiability of the function. Check continuity and differentiability. This type of question they are asking over some interval, over some point, at some points they are asking. Number 1. Number 2, sometimes they are asking that find the number of points of discontinuity. So points of discontinuity they are asking, number of points. Sometimes they are asking find the total number of points where the function is not differentiable. Points, number of points of non-differentiability. How many points are there where the function is non-differentiable? So this type of questions like 15 to 20 we are going to solve in the next video. Now topic of the video is continuity and differentiability. Okay, now these topics we are going to discuss. So now all of you, I hope enjoy this class. Okay, now be attached with me and don't forget to subscribe my channel, subscribe it and press the bell icon so that you will be updated with every videos. And in the next video we have a very exciting episode regarding the continuity and differentiability. Till then, bye, have a nice day.